This is Rangaswamy, Associate Professor, Department of Mathematics, BMS College of Engineering. We are introducing an elective called number theory. Number theory is a branch of mathematics application in engineering. So, in 1801, mathematician Gauss introduced the concept called congruence. In earlier mathematicians, they are giving much importance about prime number, perfect number, etc. They are very much concentrating about prime numbers. So, Gauss introduced the concept congruence. So, example definition. Let m be a positive integer. M be a positive integer. A is congruent to an integer m if m divides a minus b, then we can write symbolically a congruent to b mod m. Examples: 5 divides 23 minus 3. We can write in symbolical form 23 is congruent to 3 mod 5. 3 mod 5. Suppose does not divide 20 minus 3. We can write 20 is not congruent to 3 mod 4. In congruence, we have some properties called reflexive property, symmetric property, positive properties. Using congruence, in earlier don't have calculator on computers, they used to find whether remainder or the last integer when divided by some number. Example, we can find the remainder when 3 power 247 is divided by 17. The 3 power 247 is a very big number. You can find the remainder when divided by 17. Similarly, we can find the last digit in decimal value of 1997 power 1998 power 1999. And also we can determine that 11 into 14 power n plus 1 is a composite number or not. And I am into another concept called linear congruence. Linear congruence. Example: 9x congruent to 6 mod 12. Linear congruence. So the linear congruence, whether it has you can determine how many solutions it has. The linear mod m is solvable if and only if d divides b, where d equal to and m. If d divides b, then it has d number of solutions. Example: 12 congruent to 48 mod 18. So the GCD of 12, 18 is 6 and 6 divides 48. It has 6 number of solutions. Problems like x congruent to 1 x congruent to 2 x congruent to 3 mod 5. So it's called simultaneous equation. You can solve using Chinese remainder theorem. That's very lot of application. They are called three milestones. The first one is called Wilson's theorem. Wilson's theorem. If P is a prime, then if P is a prime, then minus 1 to minus 1 P. It has a lot of applications. Another one theorem called theorem. Let P be a prime and A, let P be a prime and A any integer such that P does not divide A, then A power P minus 1 is congruent to 1 mod P. So, application part is you can find the remainder when 24 power 1947 is divided by 7. Using Fermat's theorem, we can solve this problem. And Euler introduced another concept, Euler phi function. It has very lot of applications. Euler's theorem states Euler's theorem let m be a positive integer and a any integer with GCD of am equal to 1, then a power m congruent to 1 mod m. So, you can find the remainder when 245 power 1040 is divided by 80. Actually, a very big number. Nowadays, you can calculate, you can compute the remainder using computer. In earlier days, we don't have calculator and computer. So, these theorems plays very important role to solve such problems. And if you come across like computational number theory, you can factorize a big number using Fermat's method, and you can reduce a number into a continued fraction. Continued fraction is very much important. Finite number, finite continued fraction, infinite continued fractions. And you can solve even quadratic congruence. So quadratic residues, the legendary symbol, quadratic reciprocity symbol, They are very much useful in engineering. And arithmetic functions. In arithmetic functions, you can find sigma functions, tau functions, Dirichlet product, Dirichlet inverse, Mobius functions, and Euler's phi function. It has very much use. It is very much useful, and you can find primitive roots and indices, the order of a positive integer, primality test, primitive roots of primes, and the algebra of indices. So number theory is very much useful in engineering.